Alright, good morning guys. This is another Solidworks quick tip that I'll be bringing you. This one's not so quick. Normally I'm a pretty proficient person, and this one stumped me for a couple of days. I searched all over the internet for a solution and thought I was stumped and wasn't even sure if I was going to be able to bring a video to you guys that made sense, and then I finally found a solution. I'm still a little up in the air about it, but I'll kind of explain as we go on. So as you can see in the picture here, what we have is we've got this cross tube here that we're going to be working with. And a lot of times when you're frame building, you'll find that maybe you've got a bigger tube that needs to come into two smaller tubes or one smaller tube. And at least in the BMX industry, the common thing to do is to crush the end of the tube or ovalize it. And that way it fits across the entire tube without sticking past. There's different styles, right? And one style being this open tube down here, and then this style being mitered ends. So what I was trying to do originally was work off of the perimeter of a circle. So perimeter of a circle is simple. It's pi d. And then there's a formula for perimeter of an ellipse or an oval, and it's a little bit more complicated. And do I even have it up anymore? I don't believe I do. So there, an approximation. This is a pretty bad one, but this formula right here is an approximation. There's a better approximation. This is, by the way, mathisfun.com. The approximation I was using was this guy, Raman approximation 3. And that ended up being a rabbit hole, right? That was a total disaster. I was trying to get A on the other side of the equal sign, and it ended up coming up with a formula that was about a page long. I kid you not. In fact, let's see if I've got it in my history here. So the next page you're going to see is the actual solution to the formula. And it's one of 4. There's 4 solution sets. So this guy eventually helped me. I got some help, and he obviously was a super smart math person. And basically this is the answer. That's just one set. There's the second set. There's the third solution set. So I was not going to even attempt to plug that into SolidWorks or anything else. So going back to the original formula for ellipses, all of a sudden it occurred to me that the area has to remain the same as well, not just the perimeter. I was thinking that when you crush it, the perimeter stays the same. Well, the area stays the same. Area formula is much easier. It's pi times a times b. And so that's a lot easier to work with. Get that out of the screen there. And that's something that I plugged into SolidWorks here. I set the formulas up ahead of time. So under equations, I have area of tube, which is also area of ellipse. I have the tube diameter, half minor axis, which is B, half major axis, which is A. So right now I have dummy numbers plugged in just so I could enter the formulas into Excel, and I'm going to do the geometric part first. So we're going to work on this tube here, and what we're going to do is we're going to go into this sketch and we're going to actually split it into 3 pieces. And the reason for that is that we want to have the tube stop short. So you'll understand here in just a second. Sketch tools. I want to split entities. There we go. Go there, there, and then we'll set these equal. And we'll dimension one side. And we'll transition it over 1.5 inches. Oh, that was 1.2. And then what we're going to do is we're going to turn these constructions so SolidWorks will ignore them for the tube rebuild. And we're going to go back. And it failed. That's okay, not a big deal. So it dropped the group because this was probably the one it kept track of, but anyways, not a big deal. And our trim's we're gonna ignore that trim right now too. So let's see, why do we have some stuff turned off here? Turn that back on, turn this back on. Now what we're gonna do is we're gonna go with an oversized tube just to show this better. So we're gonna go with, let's say we go with, let's go 1 inch 065. Okay. Now we're gonna flatten that out into this tube here. And so what we're gonna do, we're gonna start a new sketch, and since this is a straight tube, we're just gonna start a sketch at this point over here. Do I have anything there besides cross brace sketch? We'll show that. So we're going to create a plane. And what we're going to do is we're going to start an ellipse. So we're going to go ahead and draw. We're going to go ahead and sketch on there. And we're going to draw an ellipse. Yeah, it doesn't matter which side I'm on. I prefer to be on the left side because I'm left-handed, so arg. I'll fix it in a second, guys. So what we're going to do is we're going to actually put those, well, we don't really have to. We can just click here and here and hit horizontal, and then here and here and hit vertical. Okay. And I'm going to get out of here and flip that, I'm going to flip this over real quick. Oh, come back. Alright, now we'll get back into the sketch. I did some wacky thing with my tube. And really we don't want this tube, we actually want this tube aligned, so first of all I'm going to turn that off and move that up. Oh, I can't right now because I'm in the sketch. So I want to find the sketch that this is on. We'll just, oh, right there. There's the developed one, or there's the, we'll just use this one. So I'm going to actually take away those two constraints, and I'm going to bring this up and attach it here. Oops, undo. Yeah, no kidding. So I want to divide the difference there, and I've got some things to work with here. Up here, and then we'll get this sketch 169 under that, and we'll edit it. And what we're going to do is we're going to set this equal to this times 2. Alright. And so what we're going to do now is we're going to crush this tube down to that size. This is a little extreme now that I'm looking at it. But this is probably what you'd have to do to get this tube to fit completely onto that other tube. So we'll have a look at it. So first thing we're going to do is we are going to loft, and we're going to pick we're going to do a thin feature, And we're going to do 0.065. We're going to go from here to here. And we're going to make sure that our normal is lined up, which of course it's not. You want the, oops, don't want it to flip over like that though, but you want the normal to go through the center. And it thinned on the wrong side. Alright, now we're going to trim that out. And I'm going to guess it's not going to quite trim correctly. It certainly isn't going to trim normal like, well, yeah, that's a whole nother story. So, we'll trim that out real quick. I don't think trim's going to work on... Oh, you know what? I need to merge that. I'm going to merge it with this tube. And we may or may not be able to trim. We'll see. Oh, we can. Look at that. So for right now, we're only going to use, we're going to actually stop and mirror that over real quick. And so we're going to mirror this feature. Yeah, I wonder if it'll do geometry pattern. No. So what I'm going to do now is I'm going to create, let's see, actually I'm going to do, I have to think about this for a sec, guys. I think I'm stuck with, oh, you know what? I can cut the tube in half. So let me update the sketch here. No, split into these right there, and then we'll set these two to be equal. We'll do that, and we'll make this run along X as well. Bodies to mirror this one, and then we're gonna merge them. And we're going to see if the trim will still work. It does. Mamma mia. So, the trim works, everything works. I'll kind of roll up and go back through this real quick. I got one more thing to do. That is just a little too tall. So we're going to go 0.24. And now what? Why does it not like it? Oh, did I lose my loft? Actually gonna isolate this. Now I'm gonna shell it. Yeah, I'm starting to get like pinching right here. It's so thin that it's starting to crush the tube. So what that would tell me, this tube may be too big, but irregardless, I could have drawn an inner radius and probably did okay. But it is starting to get extreme, the flatness. I understand what's going on now. So then we'll go mirror. Oops, no. Now we gotta combine the two. Now we're going to mirror and trim. And what we're going to do is we're going to go to like 2.23. So I'm getting, it's just hitting funny over this, on this side. I know what I'll do. I think I could have solved this a long time ago. So I left this unconstrained. I'm just going to move it up the curve a little bit. See if that fixes it. It's ugly. Get rid of that piece. Discard. Alrighty. So I'll recap here in just a second. Because this isn't really the exact, this isn't the exact shape that the tube would take. This is going to be like the longest video ever. Alright, so let me recap. Let me roll it back. So what I did is I have that original sketch there that was this cross tube. So the original cross tube was smaller. This tube's 1 inch, this tube's half. That's roughly double the size. It's kind of a poor example. It can be done, but even the way you would crush the tube, most people aren't going to use a form. They're just going to put it in some sort of vise mechanism. So the way it's being drawn here is not exactly right. So what we did is we had our tube go all the way across. The original sketch, excuse me, I split the line. So got 2 halves and then 2 areas where we're going to generate the crush or the squash. Generate the half the tube, and then we're going to roll down here. Generate the loft. Make sure the loft is inside the tubing so it trims off correctly. Then I had to shell it out because it wasn't wanting to do a thin feature, and it still gave me warnings in the shell, and I just accepted it because it's visual representation, right? And then I combined them, mirrored it across the center line. So there's my tube, and then I did a combine and trim. So I combined it into one tube and then trimmed. And you end up with this kind of funny, how you'd even guarantee this, I don't know. You would have to crush the tube, and then you'd have to take some guess passes with your tubing notcher. You'd want some sort of jig so that you could reproduce it every time. So once you got to a certain look, you'd want to be able to reproduce your crush, and you'd want to be able to reproduce your trim with your tubing notcher. So this would take some time. This would be a lot of hand work and getting some things set up that once you got them set up, you wouldn't want them to change. So I don't know how feasible this is in real life. I think that you'd end up with more crush. I think these would end up looking probably more like probably something like 2 inches at least. See if it'll even rebuild. And of course it didn't. And I must be having a problem with Solidworks because I don't see it. I don't see any failure warnings. Let's see if it'll even save. Why am I not getting any warnings? Oh, I know why. For some reason, SolidWorks has been doing this to me lately. They are hidden somehow. What is going on? the trim's... It's the trim. I couldn't figure that out. The trim command seems to be sometimes very problematic. Sometimes it'll, even after you've saved, it'll, when you rebuild it, keeps the wrong body. I don't know why it does that. Hey SolidWorks, there's something else for you to fix. So it did rebuild. I still think you might even flatten it more than that, but that's getting closer to what I would think real life might look like. So anyways, guys, I know this was the long way around the bush, and I know this wasn't exactly a SolidWorks quick tip video. This took me days to figure out this ellipse thing. So, and knowing what I know now, I think I would actually change it to something more like an oval, or I mean a slot shape, where you have ellipses that meet flat sections. And I'm sure that would be real fun, trying to figure out the area of that. So, guys, as obscure as this is, I hope it helps somebody, and I'll talk to you later.